Our group has chosen Chihua Learning Commons, located at the University of Hong Kong, to be transformed in the future. Our design encapsulates a much more intelligent environment that is responsive, meaningful, and enjoyable. There are a few problems that we have observed in Chihua Learning Commons. The major problem was the fully occupied tables. HKU students often have trouble finding a vacant seat, and the process takes plenty of time. During summer, disturbing amount of sunlight would also enter the building. Besides, noise from book study rooms has been a slight issue. There's no viable area for debate or discussion. So how can we solve the problem and use the space effectively?
As we all know, Chihua already has tables and chairs filled to the brim. We would have to create space elsewhere. Our group came up with a solution utilizing the empty, unproductive courtyard.
The home scheme developed by FarmLab has shed some light onto the situation. They came up with a design on the outer walls of buildings in New York to provide shelter for the homeless. We have came up with a similar design. The hexagonal cubicles, much like honeycomb, provides a rigid, strong, and compact structure, able to accommodate plenty of students.
The interior of the cubicles will contain furniture, like tables and chairs for students to study. Each cubicle can be accessed via a magnetic levitation elevator on each floor, which stops in front of the study rooms on the exterior. Instead of using traditional mechanics, they travel on a maglev track. Because of this, more than one elevator can operate on the same track.
The architecture will be built by using several smart materials to solve the problems. Firstly, the windows of beehive structure will change to red color to alert the room users to lower their volume. Let's take a closer look. Piezoelectric sensor can be placed in the study room to detect sound vibrations. This material converts mechanical energy to electric energy that passes through the window. Electric current is produced when sound energy reaches a certain level. When electric current passes through, the window will change into red due to redox reaction. This warns the user to lower their volume. Installation of motion sensors are also plausible, allowing the glass to change color to green to indicate the room is empty through the same mechanic. Secondly, the window will be a soundproof window to reduce the noise from disturbing students in Chihua. By using laminated glass, the PVV layer of plastic between glass stops vibration. Moreover, the airspace between color-changing window and soundproof window isolates sound vibrations. Last but not least, the perovskite solar window will be also used. This window turns dark when the temperature is above a certain degree. By darkening, it can reduce direct sunlight from entering the study room and provide automatic shade. Moreover, it can also absorb solar energy and become solar cell, which can generate electricity for lighting or air conditioning in the study room. With all that in mind, we should be reminded that our design is a proof of concept. The same architecture can be applied to multiple buildings with different functions.